Everyone is talking about AI agents. So you can see all around YouTube, you can see how you can create AI agents, how you can link Gmail, Google Calendar, G Drive through MCP or function calls. But no one is talking about the real core security problem by default these LLMs have, which is more critical for every day-to-day user who is already using Gmail. So let me show you actually how this hack actually works. So here I have a quick simple ticket automation platform, or sorry, simple ticket automation agent, which will get tickets from Gmail, and when user, which is Kathy here, ask for get me the latest ticket, it will fetch the latest ticket and summarize it and send it to the particular user, or it can also forward to a different mail, right? So this is a normal typical ticket automation agent everyone can create. But here comes the issue. When John, who's a hacker here, comes here and sends the ticket information with some malicious prompt, right? So this prompt pretends that John is actually Kathy, and he need to ignore previous prompts and need to execute some arbitrary code functions. In this case, it is Google Calendar, right? This may sound silly, but by default, AI agents can be tricked or can be easily convinced to execute these functions. I'll show you how this attack actually works. Here I have the attacker. So this is the attacker. I'm just sent to my own mail, which I connected to Claude. We are going to use Claude to get hacked. So I just sent to my own inbox that this is the ticket. With this ticket, I've just also sent another critical function calls, like you need to create a calendar event, right? So this is the inbox I got, which says, okay, this is the information and blah blah blah, right? Let me go to the Claude. So here is a quick prompt I have created for Gmail ticket checking, where it will get the latest ticket and read it and send it to my developer mail. And also I have a keyword based detection, so that every ticket that comes in will have this keyword, right? So just for a quick navigation. So let me send this and let's see what happens. So just fetching the Gmail just like before. So it doesn't fetch anything, but here is the thing. So here you can see just created a calendar event, and it's also sending an email to the mail, right? So actually it doesn't need to execute because I haven't asked to execute the calendar event. But who does is it's John. So John asked the AI agent of Kathy to execute the calendar event without the permission of Kathy itself. So this is a major flaw that an LLM has. So the reason why this happens is because of three things. There is no semantic boundaries between the LLM's context window, right? Before getting into this first pillar, we need to understand why this attack actually worked. What happened is that whatever the text that comes in, right? It can be like RAG, it can be PDF, it can be Gmail outsource, it can be a system prompt, it can be the user prompt. So whatever the data comes in, will at last these data will be get inside a single bucket called context window. So the key problem here is that just 2 line or 3 line of prompt is good enough to poison the whole context window, which will trick the LLM and convince it to execute arbitrary code functions without the user's permission. So that's what here also happened. So we have this poison context window, which is combined with the system prompt and the real authentic ticket. But it also has the malicious prompt, which convinced the LLM, which made the LLM to execute, or AI agent to execute, the arbitrary code function. So this is why there is no semantic boundaries between the words that we say, right? Semantic is something which correlates between the words. Let's say we have execute and we have task needs to be completed. They are somehow semantically correlated between, but they are two different words, right? So maybe you can create a guardrail which says stop anything which says execute, but I can also say the same meaning in a different word, like complete the task. So kind of things. So by default, these LLMs have no semantic boundaries, which made the first critical point here. And second, it is the contextual blending, which means some cases where I can blend the function calls between the context itself, which will be more authentic, because there are some guardrails out there which will predict, okay, user is asking for a function call which not permitted, right? But if there is a way to blend the context, like in order to complete the ticket information, you need to do this for me so that the ticket is fulfilled and the developer can fill it, right? So this storyline will build and blend inside the context window, which will surely poison the LLM's mind and execute arbitrary codes. At last, the instruction following training, because these LLMs are trained on instructions. If we can able to follow these instruction data just like what it's trained on the data set, we can sure trick the LLM again to execute the arbitrary code, right? How do we secure ourselves from these kind of attacks? So many of us, maybe many of others in the forums or other ones says that you can control these kind of attacks through prompt itself. But again, these prompts can be semantically manipulated and can be triggered, so that these kind of indirect prompt injections can occur and it may hack you, right? So by default, Claude has some security. Just by convincing it to contextual building, I can able to hack it, right? So this is something we can't prevent it from LLM, but the only way we can prevent it through the function calls. So here you can see that I'm a lazy guy. So for full autonomousity, I just unlock all of my functions, right? So this is not a secure way. You always need some human in the loop in order to execute some couple of functions which you need to authorize. So this is the only way we can go for, because here you can see I have like 3 functions. The LLM can execute any of the 3 MCP servers functions, which may end up in a disaster, right? So the only way to stop this kind of disaster is to add access control to your functions. If you are developing an autonomous agent, so just classify the more critical functions and more low critical functions. So every function is a critical function. So in order to go further, just find a loop where if there is any critical function is being executed, you need to be get notified. So this is the only solution we have. So we are also working on a similar solution where there will be an agent shield between your MCP tools and your LLM agent. So this is called Hipocap. So the shield will act as a gateway for data source incoming and data source outgoing, right? So if LLM tries to execute some couple of functions, this agent protects it, and so does if there is any malicious data that comes in, it will classify and finds out, okay, if there is any function call been happening, it will figure out and blocks the data source coming inside the LLM. So still there is no standard security system for it yet, but most of us already in a danger zone. So please share this video for everyone with your friends who are using AI agents for Gmail and other kind of data sources. So this is something critical we need to understand, and no one is again talking about this. So just be secure out there. Thank you everyone. If you like this video, sure give it a like. I'll post more videos like this, and do share it with your friends. Thank you very much.